Hello again, Algebra 2 class. This set of videos is on Chapter 7, Section 3 from your Algebra 2 textbook. This section is on independent and dependent events. We have two main objectives today. The first is to determine whether two or more events are independent or dependent. Once we've determined that, our second objective is to actually calculate the probabilities of these independent and dependent events. This first video will be just determining whether events are independent or dependent. So we'll need some definitions for what those words mean. Events are independent if they do not affect each other's probabilities, and they are dependent if just the opposite is true. They do affect each other's probabilities. One way that I like to think about this is to ask myself the following question. If event A happens, does the probability of event B happening change as a result? So, does event A happening affect the probabilities in event B? So we'll start with an independent event example. You flip a coin twice, determine the probability of getting heads the first time and tails the second time. So let's think about what's going on here. If we flip a coin and we get heads the first time, does that change the probability of getting tails the second time? Well, as long as we're dealing with a fair coin, it doesn't, right? The probability of getting tails is just going to be 1 out of 2, no matter what. Or more specifically, no matter what the first flip was. This is why this is an independent event. The outcome of the first flip does not affect the probabilities in the second flip. Let's look at the exact opposite in this next example. Let's say we have a bag with 2 lemons and 1 lime in it. And we want to determine the probability of pulling out a lemon first and then a lime. And we're not going to put the fruit back into the bag in between picks. So let's first consider if we pull out a lemon on the first pick. Well, that would mean our probability of getting a lime on the second pick would be, well, let's see, we have 1 lime left in the bag and 1 lemon left. So that means we have 1 lime, which is our success case, out of 2 total fruits. On the other hand, let's consider now if I pull a lime out the first time. Well, now my probability of getting a lime on the second pick changes because in this case I now have 0 limes left and 2 lemons. So I have 0 success cases because there's no limes left out of 2 total. So we can clearly see these two are different. Our first pick changes the probability of our second pick, which is what makes this a dependent event. One last thing that's worth mentioning in this context is this idea of replacement, which we just looked at in the last example, actually. Replacement is whether or not you put an item back after you pick it. So if you see the phrase with replacement, that means after you pick out an item, you put it back into the bag or box or deck of cards. This will generally lead to independent events, because if you're putting the item back, it doesn't really matter what you picked the first time. It won't affect the next pick. Without replacement means the exact opposite. You do not put the item back. So this is what we just looked at, right? You take the lemon out, you keep it out, you don't put it back. This will generally lead to dependent events.